Okay, in this section 6.5, we're really focusing on rationalizing the denominator, right, of a radical expression. So when it comes to radical expressions, we never want a radical in the denominator, right? So the radical in the denominator must be multiplied by another radical in order to eliminate the radical in the denominator. All right. This process is called rationalizing the denominator. So let's take a look at some examples. We want to rationalize the denominator. I have the square root of 7 over 3. All right, so the square root of 7 over 3 is just really the square root over 7 over the square root over 3. Here we can clearly see the denominator has a radical, and we need to get rid of it. So what we can do is if we multiply this by the square root of 3, we will see that it will disappear, and I'll show that in a few steps here. But let's not forget one thing that we learned with fractions, just like with equations, what we do to one part of the fraction, we must do to the other part. So if I'm multiplying the bottom by a square root of negative 3, by the square root of 3, I have to multiply the top by the square root of 3. Because now we're left with the square root of 7 times 3 on the top, and on the bottom we're left with the square root of 3 times 3. And in my previous video, I talked about how this really has a 2 as the index. We're pulling in groups of 2's, which means this can come out to the outside, right? So on the bottom, we're only left with the 3, nothing inside the radical, and and on the top, we can't pull anything out, so we just leave it as is. So this answer here is the square root of 21 over 3. As you can see, our denominator no longer has a radical. Okay, example B. How about the third root of 7? I'm sorry, let me start this over. How about the third root of 7 over 25? So let's once again write it as 2 of them. Third root is 7 over the third root of 25. All right, let's take a look here. This example, a little different from the previous one because our index is 3. All right, if we prime factorize, right, top we can't do anything, but we know that 25 is a 5 and a 5. So now we have 5 times 5. Right? So now the question is, what do we have to multiply this by, right, in order to get rid of the radical on the bottom. Let me extend that a little bit. Well, what if we multiply by another third root of 5? Keep in mind, these must be the same, right? Because we learned this property earlier, right? That the indexes must be the same, right? It was taught in a separate section. Okay, so if I multiply the bottom by the third root of 5, then I also have to multiply the top by the third root of 5, right? Because now we're left with the third root of 7 times 5 on the top. And on the bottom, I'm left with the third root of a 5 times a 5 times a 5. This time we're pulling in groups of 3s. These 5s can come out, right? We're left with nothing on the bottom and the inside on the bottom, right? So it's just 5 on the out 5. And then we're left with the third root of 7 times 5. Right? We're just left with the 35. So this example B is a very nice example, one that I encourage you to practice. Let's take a look at maybe one more like that, because I know that's always a tricky one on the homework. How about we include a variable in there? Let's do the third root of, how about 3a over 5c? Okay, so this is the third root of 3a over the third root of 5c. Okay, so what do we have to multiply them by, right? I'll show that in the next step. Remember, we need 3 of each, right? 3 of each because the index is 3. So how about, I have one 5c, that's a second 5c, and then how about, there's my third 5c, right? And if I do that to the bottom, I also have to do it to the top. All right, let's show our next step up here. So now this is the third root. I'm going to put my numbers next to each other first. How about 3, a 5, and then I got an A, a C, and a C, right? That's on the top. And on the bottom, I have, once again, the third root, and I have 3 5s in the bottom, and I have 3 C's in the bottom. So I see I can pull out a 5 and also pull out a C. I'm no longer left with anything inside the radical. On the top, I can't pull anything out at all, right? So I just multiply those numbers, right? 5 times 5, 25. 25 times 3 is 75. So 75a. And then I got c to the power of 2. Right, so example C, a nice example. Let's see. Maybe let's take a look at one more like this. Once again, I know that these are ones, especially with this cube root, that get students all the time. Taking a look at your textbook here. How about we do, how about this one? How about we do the third root of the 7c over 100 AB to the power of 5. That looks like a really nice one. Okay, so this is the third root of 7c over the third root of 100 AB to the power of 5. Right? We can't do anything with the top. We can't break that up any further. But this 100, all right, well, that's 10 times 10. All right, and this is a 2 times a 5. And this is a 2 times a 5. All right, so now we got third root. I got a 2, a 2, a 5, a 5. And I have 1A, and I got 1, 2, 3, 4, 5 B's. I'm pulling in groups of 3s. I don't see any right now, but I see these. How about that? That comes out. All right, so now I'm left with the third root of a 7C. We pull out that B, third root. I'm going to bring everything else still down. I'm not multiplying any of it yet, okay? Remember, we want to rationalize the denominator, right? Which means we need to get rid of this radical symbol on the bottom. So what am I going to multiply by? Definitely a third root. I see 2 2s, which means I need one more 2 to make 3 of them. I see 2 5s, which means I need one more 5 to make 3 of them. I see 1 A, which means I need 2 more A's to make 3 of them. I see 2 B's, which means I need one more B in order to make 3 of them. All right, so this is what we're going to be multiplying by. So I did it in the bottom. Now once I figured it out, I just rewrite that on the top again, right? 2 5 A, and a B. Okay, now we can just show 1/3 root. I have put the numbers first. I got a 7, and then on this other side I got a 2 and a 5. And then I put my letters next. I got a C first, and then I have an A, and a B. Order really doesn't matter. I bring my B, right? That B comes down, 3rd root, and now I see I got 3 2s, 3 5s, 3 A's, and 3 B's. So again, I'm pulling in groups of 3, so now I can pull out a 2. So 2, I could also pull out a 5. Don't forget my B. B times 2 times 5 times, pull out an A, and I can pull out this B. What about on the top? Anything? 3 of anything? No. So how about we just multiply that? 7 times 2 times 5. 7 times 2 is a 14. Right, times our 5, that gives us a 70. I'm left with the 1C. I'm left with 8 to the power of 2 and a B on the top. And now I just simplify the bottom part out. I rewrite the top. How you write these variables shouldn't matter. But in the bottom, we definitely want the numbers to go first. 2 times 5 is a 10. I have an A, and then I have B to the power of 2. So some nice examples of rationalizing some of those. And I think example D is one really that you want to understand. It's a good practice one. Okay, so let's continue here. All of these examples we saw that are really just one term, right? But what if our denominator had 2 terms, right? So if your denominator has 2 terms and a radical, within it, we multiply by the conjugate. Examples of conjugates. All right. X plus square root of 7 and x minus square root of 7. We can see these two problems are almost identical, just the difference is one has a plus and one has a minus, and that's all it really is. Square root of 3 plus x and square root of 3 minus x. All right. How about one last example? How about the square root of 5 minus the square root of 2 and square root of 5 plus square root of 2. So these are all nice examples of conjugates. Okay, so let's take a look at an example. We want to rationalize the denominator all right, I got, how about example A, 4 over the square root of 3 plus x. All right, once again, this is what we're doing. If the denominator has 2 terms and a radical within it, we're going to multiply by the conjugate. So what is our conjugate of the square root of 3 plus x? Well, it's a square root of 3 minus x. All right, because let's take a look. This really ends up being 4 times square root of 3 minus x on the top. And on the bottom, we have a binomial times a binomial. All right, this is where multiplying by the FOIL method or by distribution is going to come into play. 4 times that is just 4 square root of 3. 4 times our next term is minus 4x for the top. Then we have square root of 3 times the square root of 3. All right, we show it like this. Our next one, all right, plus, I'm sorry, that's a minus, right? Square root of 3 times negative x, right, is a minus x square root of 3. This x has no radical, so it goes in front of the radical. X times a positive square root of 3 is a plus x square root of 3. All right, then we have x times negative x. Well, that's a minus x squared. We learned this in a previous chapter. We see that these cancel out. Right, we're pulling in groups of 2, so that's going to come out. Can't do anything to the top. We pull out a 3. Those cancel, and we're left with minus x squared. And as you can see in our answer, we no longer have a radical in the denominator. And how about one last example here? I have 4 plus the square root of 2 over the square root of 5 minus the square root of 2. So we want to multiply by the conjugate again because we want to get rid of these radicals. All right, so we have 4 plus the square root of 2 over the square root of 5 minus the square root of 2. Our radical here is whatever the denominator is, just a plus sign instead, right? We're going to show this as just one fraction instead of 2 fractions. And from here, we're just distributing again, or the FOIL method, right? 4 times that. 4 does not have a radical, right? So it goes in the front of it. 4 times the next one. Which again, does not have a radical. Does not go in the inside, but in front of it. These both are radicals. So both of those numbers go in the inside. I'm going to multiply those once again. Both are radicals, so both go in the inside. So that's our top part. Okay, bottom. Both of these have radicals, so we multiply the numbers inside. Both of these are radicals, so we're going to be multiplying those numbers inside. A negative and a positive, right? Gives us a negative there. A negative and a positive also gives us a negative. The bottom, we're multiplying radicals everywhere, so we have all radical symbols there, right? Okay, let's continue on. Let's take a look here. What happens? The top, we can't do anything, we multiply those, and we can pull that out. So we're left with 4 square root of 5 plus a 4 square root of 2 plus a square root of 10 plus 2 over, well, that's going to come out into 5 plus, that's a 10 minus, that's a 10 minus, hey, that's also going to come out to 2. Well, you see, these cancel, don't they? So we're left on the top with the 4 square root of 5 plus a 4 square root of 2 plus a square root of 10 plus a 2 over We can do 5 minus 2 gives us 3. Once again, you can clearly see no radical in the denominator. So some very nice examples of simplifying radicals. If you have any questions, please, by all means, email me. Thank you.